Hey everybody, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're looking at Unit 7, Lessons 4 and 5, which is about solving linear inequalities. And so when we are solving a linear inequality, it's very similar to what we do when we're solving a linear equation, but there are just a few small differences. And so I grabbed this table from our lesson because I thought it did a good job of telling us that the main thing that's different when we're solving a linear inequality is that we may have times where that inequality symbol is going to change directions. And so this table on the left side here are things that happen as we're solving that are not going to change the direction of that inequality. On the right side, and these are the ones that we kind of want to focus on today, are the things that are going to change the direction of the inequality. So as we're solving an inequality, if we have to multiply both sides by a negative value as we're solving, or if we have to divide both sides by a negative value as we're solving, that's going to change the direction of that inequality symbol. And we'll see some of our examples here as we work through some problems. But so anytime you're multiplying or dividing by a negative value as you're solving, it's going to change the direction of that inequality. And they also include here if you're reversing the sides of the inequality. And basically what they're saying there is, let's say I had something like 5 is greater than x. If I switch the sides, if I move the x to this side and the 5 to this side, we're also going to need to switch or change the direction of that inequality symbol. So these two expressions are the same, but that's what that third example there, or third thing in the table is referring to. All right, so let's jump into some examples. So this first one, we want to solve this inequality for x. We have 5 minus 6x is less than 23. So just like we would if we were solving an equation, if this was an equal sign here, we want to get that x term isolated or by itself. So I would start solving this by subtracting 5 from each side because I want to get that x term by itself. That's going to leave me with negative 6x less than, and 23 minus 5 would be 18. Now, still want to isolate that variable, get the x by itself. So right now, x is being multiplied by negative 6. So to undo that multiplication, I'm going to divide each side by negative 6. And so here is an example. We are dividing both sides by a negative value. So the number we're dividing by, so this number here, we're not looking at the number that's being divided, but the number we're dividing by is negative. And when we have that, then that's going to change the direction of our inequality symbol. So instead of a less than, it's going to become a greater than. And so this is x, and then 18 divided by negative 6 would be negative 3. And so our solution is x is greater than negative 3. Now you can also check your work on these as well. So since we said x can be anything greater than negative 3, I can plug in a value for x that's greater than negative 3 and see if it makes that inequality true. And so the easiest one to do in this case, 0 is greater than negative 3. So if I plug in 0 for x, I would get 5 minus 6 times 0 is just 0. So 5 minus 0 is 5. And 5 is less than 23. So it looks like that is a good solution for us. X is greater than negative 3. All right, let's take a look at another example then. Got a few more that we're going to do here. So in the second one, solving for x again, we have 7 times this quantity x minus 3 is less than or equal to 35. Well, I'm going to start by, and there's a couple of ways. I could start by distributing this 7 to each term here. The other way that I could do this is I could start that 7's being multiplied by the x minus 3. It might just be simpler for me to divide each side by 7. That's going to, the 7's are going to divide to 1 and just leave me with x minus 3. And then here, 35 divided by 7 is 5. I was dividing by a positive amount, so that symbol stays the same direction. And then my last step to get that x by itself, I would add 3 to each side. Addition doesn't change that symbol, so it's still going to be a less than or equal to. and this becomes x is less than or equal to 5 plus 3, which is 8. And so x is less than or equal to 8 would be my solution. All right, in our next one here, we're solving again. This time I'm going to go ahead and start by distributing the 6 to both terms here, the 4 to both terms here. 6 times 8 is 48. 6 times negative 2x is negative 12x. We got our greater than or equal to. 4 times x is 4x, and 4 times 4 is positive 16. All right, I want to get my x terms on one side, my y terms on the other. I'm going to start by subtracting this 4x from each side. And that gives me 48 minus 16x greater than or equal to 16. I want to get this 48 moved to the other side, so I'm going to subtract 48 from each side. And I've kind of run out of room here, so I'm going to bring this up over here. So I would be left with negative 16x on the left side, and then 16 minus 48 is a negative 32 on this side. All right, and then my last step, we're multiplying the negative 16 times x, so to undo that, I'm going to divide by negative 16. And we said already dividing by a negative when we're solving these is going to flip or change the direction of that inequality symbol. So this becomes x is less than or equal to, and negative 32 divided by negative 16 is a positive 2. So our solution is that x would be less than or equal to 2. And again, I could choose a number that's less than or equal to 2, plug it into that equation or that inequality, and see if it makes it true. All right, one more example here. We've got negative x minus the quantity 1 minus 2x is greater than 5. And so anytime I have this minus and then I have the quantity, you want to think of it as we're distributing that negative to each term that's inside of the parentheses. So it kind of flips that sign. This becomes negative 1, and then a negative times that negative 2x makes that a positive 2x is greater than 5. And now we can start to solve. I have a negative x plus x would be a positive 1x minus 1 is greater than 5. And then to get the x by itself, I'm going to add 1 to each side. And that leaves me with x is greater than 5 plus 1, which is 6. And so x is greater than 6 is my solution for that one. All right, and that's all I've got for you today. Appreciate you taking the time to watch. As always, if you do have questions, please let us know. Thanks. Have a